Next question, find V naught. So here a series RLC circuit is given across which you are applying a voltage 1 by 3 e raised to minus 3t, and we need to find out the drop across one particular element. So first let's draw the circuit in S domain. So in S domain, R will be in S domain, R can be written as 6 itself. Inductor value is 1, so it will be S. Then capacitor 1 by 8 farad should be written as 1 by CS, so it will be 8 by S. The input is 1 by 3 e raised to minus 3t, so this will be 1 by 3 into 1 by S plus 3, and this voltage is V naught of S. So we need to find out V naught of S. We can directly apply the equation. Voltage across one particular element equal to total voltage applied into that particular impedance. Here it is 8 by S divided by the total 6 plus S plus 8 by S. Okay, so this on simplification we will get as 8 by 3 into S plus 3 into S square plus 6S plus 8, which can be written as 8 by 3 into S plus 3 into product is 8, sum is 6. So S plus 4 into S plus 2. Okay, can write this as 8 by 3 in the numerator itself. So this can be written as A by S plus 3 plus B by S plus 4 plus C by S plus 2. This can be simplified and we'll get A will be minus 1 by S plus 3, B is 1 by 2 plus S plus 4, and C is also 1 by 2 by S plus 2. Now we can directly write the inverse. Therefore, V naught of T equal to minus e raised to minus 3t plus plus half into e raised to minus 4t, again plus half into e raised to minus 2t whole into u of. Next question. Consider the RLC series circuit shown below. Find the expression for I of t for t greater than 0, assuming initial conditions to be 0. So first we can directly express the circuit in S domain. So in S domain it will be the input will be 6 into R of t minus 1 will be 6 into e raised to minus S into 1 by S square. This is 6, this is S, this will be 8 of S, resulting in current I of S. So we can directly write down the expression for I of S. It is V of S by Z of S. V of S is 6 into e raised to minus S by into 1 by S square divided by 6 plus s plus 8 by s. Okay, and this will be 6 into e raised to minus s by s into s squared plus 6s plus 8, which can be written as 6 into e raised to minus s by s into s plus 4 into s plus 2. Now this can be written as, when we simplify this, we'll get it as e raised to minus s into let's do one thing. Let's take this term, that is 1 by s into s plus 4 into s plus 2 alone, and find out the value of a, b and c. Okay, so this on simplification we'll get a will be 1 by 8 by s plus 1 by 8 by s plus 4 minus 1 by 4 by s plus 2. Now we can substitute that in place of here. Therefore, I of s will be 6 into e raised to minus s into 1 by 8 by s plus 1 by 8 by s plus 4 minus 1 by 4 by s plus 2. Or this will be equal to, this will be 3 by 4 into u of t minus 1. 1 by s is u of t. 1 by Laplace inverse of 1 by s is u of t. Then what will be the inverse of e raised to minus s into 1 by s will be time shifted by 1. U of t time shifted by 1. Similarly, plus 3 by 4 into e raised to minus 4 t minus 1 u of t minus 1 minus 1 by 4 e raised to minus 2 t minus 1 u of t. Sorry, it's not minus 1 by 2, it will be 3 by 2. So this is the answer. The next question, determine current IL of t for t greater than or equal to 0. So here the circuit was closed for a long time, and at t equal to 0 the switch was open. So we need to find out Vc of 0 minus as well as IL of 0 minus. So for that, let's draw the circuit at t equal to 0 minus, which corresponds to steady state. So the switch is closed. The switch is closed. Capacitor replaced by open circuit, and inductor replaced by short circuit. This is 4, 2 and 6 volt. So what will be IL of 0 minus? Just one loop circuit. IL of 0 minus will be 6 divided by 6, which is 1 ampere. And what will be Vc of 0 minus? It will be Vc of 0 minus is the voltage at this point, which is nothing but the drop across 4 ohm. Total voltage 6 is applied, 2 and 4 are in series. So what will be Vc of 0 minus? Total voltage applied into that particular resistance by sum, which is 4 volt. So IC of 0, IL of 0 minus will be same as IL of 0 plus, which is 1 ampere. VC of 0 plus is same as VC of 0 minus, which is 4 volt. So while considering the circuit for t greater than 0, we will have to incorporate these two values. So let's draw the circuit diagram in S domain for t greater than 0. For t greater than 0, let's draw the circuit diagram in S domain. So the switch is open means 6 volt is no longer connected to the circuit. Therefore 2 ohm will also be floating. This 2 ohm will be floating. So the circuit will be just this loop. Okay. So let's draw that loop alone. Capacitor which have a initial voltage. So we'll have to consider that also. You will get a capacitor in series with. The value will be VC of 0 minus by S. The value of this voltage source will be VC of 0 minus by S. That is, VC of 0 minus is 4. So this will be 4 by S. The capacitor is 0.1 farad. So 1 by CS will be 10 by S. This value is 10 by S. Then similarly, inductor will be followed by a voltage source having value L into I of 0 minus. L into I of 0 minus. L is 2. 2 into 1. So this will be 2 volt. Inductor is S into L. So this will be 2S. And also there is a resistor having value equal to 4. This will result in a current I of S. So this is the circuit representation in S domain. Now we can write the KVL equation. Minus 4 by S plus 10 by S into I of S plus 2S into I of S minus 2 plus 4 into I of S equal to 0. Or from there we can write the equation for I of S. We will get I of S equal to 2S plus 4 by S divided by 2S square plus 4S plus 10 divided by S. Okay. Or this, on further simplification, we will get as S plus 2 by S square plus 2S plus 5. Okay. Now this can be written as S plus 2 by, this can be written as S plus 1 the whole square, that is S square plus 2S plus 1. The remaining is 4, which can be written as 2 square. Okay. Now this can be further split as, the numerator we can write it as S plus 2, I am writing it as 1 plus 1 divided by S plus 1 the whole square plus 2 square, which can further be written as S plus 1 by S plus 1 the whole square plus 2 square plus 1 by S plus 1 the whole square plus 2 square. Now to convert this to now what is this? S by S square plus 2 square is cos. When it is S plus 1, it will be e raised to minus t cos 2t. Now to convert this to standard form, it should be, numerator should be 2. Only then it will be omega naught by that form. So for that, let me divide and multiply the numerator by 2. So it will be 1 by 2 into 2. Okay. Now this is in standard form. We can write the inverse. The inverse will be I of t is equal to e raised to minus t cos 2t plus 1 by 2 into e raised to minus t sin 2t. So this is the final answer for current. Another question. A sinusoidal voltage 25 sin 10t is applied to a circuit at t equal to 0. Find current I of t assuming initial conditions to be 0. So here initial conditions are set to be 0, so we can directly draw the S domain circuit. So it will be, the switch is closed, R and L. R will be equal to 5. 1 Henry, we can write it as S. Input is 25 sin 10t. So 25 into sin 10t, Laplace is omega naught by S squared plus omega naught squared, resulting in a current I of S. So I of S can be written as V is 250 by S square plus 100 divided by S plus 5. Okay. So this can be written as AS plus B by S square plus 100 plus C by S plus 5. On simplification, we'll get it as minus 2S plus 10 by S square plus 100 plus 2 by S plus 5. Now this can be split as minus 2S by S square plus 100 plus 10 by S square plus 100 plus 2 by S plus 5. Now all these are in standard form. We can directly write down the inverse. I of t equal to minus 2 into S by S square plus 10 square is cos 10t plus omega naught by S square plus omega naught square, that is sin 10t plus 2 into e raised to minus 5t the whole into u of t. This is the answer.